So my question to you, did you figure it out? This is the example problem that we left off with, and it gave you A, B, and C. How do we make these compounds based on what we have discussed together in the lecture material? So let's start with A, and you're going to find out that these were very similar and maybe even easier than the ones that we did together. So the question, were you able to give me a correct answer for these? All right, so let's take a look at A. With A, they give me a benzene ring, and off of this side is a NO2, and off of this side is a C double bond O with a CH3. All right, so this is what they want me to make. And I need to make this starting with benzene. Okay, so I take a look at the groups that need to be added onto the benzene ring. I have a nitro group that's going to include nitric acid and sulfuric acid as a catalyst. And then I have this group, which is an acyl group, a C double bond O with a CH3. So this acyl group, I know we can add on with a Friedel-Crafts. So I'm going to add that on using Friedel-Crafts and some aluminum chloride and probably some water. Now, the order is very important. Let's talk about the nitro group first. With the nitro group, this is a deactivator, one of the best deactivators on the chart. It's the lowest, one of the lowest. And because of that, it's a meta director. If I look at the AC or acyl group, the C double bond O, this is also a deactivator. And that deactivator as well will be a meta director. They both show up at the bottom part of the charts. All right. With that said, is one way better than the other? And the answer it is. Of course it is. You know that it's going to be. So what's going to make this decision for me? Keep in mind, these are meta of each other. I can see that with the structure. Both of these are meta directors. That's not going to determine my decision. But what will is that we've already discussed again and again and again that Friedel-Crafts cannot happen if there is a deactivator that's already on the ring. So what that means is that if I have to choose between the acyl group and the nitro group, I better do the acyl group first. Because if I do the nitro group first and I bring that group onto the ring, what's going to happen is that group will deactivate the ring and it will make it very stubborn, and I will not be able to add the acyl group onto it in the second step. We already said that. Deactivators make the ring less reactive. The Friedel-Crafts was already pretty stubborn, and we just don't get products when that happens. So the very first step I have to do is take my benzene and I have to acylate it using the aluminum 3-chloride and water. And what happens is that a group goes on, and I'm just going to put it where it goes because, folks, I get the freedom to do that. It's going to go onto any carbon, it doesn't matter, but I'm going to make it match the product that we need to make. Perfectly fine. So C double bond O CH3, I'm going to draw right here in the top right hand corner, and there's the acylation step using Friedel-Crafts. Now that this group is on, this group is a deactivator and it is a meta director, which is great because that's exactly what we need. So now I need to add on the NO2 group in the meta position. So in order to do that, I'm going to add HNO3, and then H2SO4 has to be on the arrow for a catalyst. So what I'll end up with is a C double bond O CH3, and then OM P, Becky, there's my M, and this is an NO2 group that adds on to that location. All right, so there's the synthesis. It's multi-step, and in this case it was just 2 steps, but it's still multi-step in order to form that product. All right, so with that done, let's go, or finished, let's go and take a look at B. B's a very similar story. They want you comfortable with this idea of when you can and cannot use Friedel-Crafts. That's why they're doing this on you. All right, so with B, it looks like I have a benzene ring. And again, I have an acyl group on it. So I'm going to have to Friedel-Crafts it. And then down here, I have an SO3H. How do we do this? What order do we do it in? All right, not a big deal. We've already kind of talked about this already. I'll take my benzene. I know that I'm going to have to Friedel-Crafts it first, because if I don't, that SO3 group, folks, that is a deactivator for me. And that deactivator is going to deactivate the ring and not allow Friedel-Crafts to happen. So I'm going to have to do that step first, just like I did with part A. So aluminum 3 chloride and water, and that will slap this C double bond O, CH2, CH3 onto the molecule. All right, with that said, we now have a deactivator on the ring. That deactivator is a meta director, and that's perfect because OM, that's exactly where I want that group to go. So what is that next group? It is an SO3H group. How do we put that group onto a benzene ring? Folks, we take sulfuric acid and we put it with some more sulfuric acid. Basically, that's how we write it in the reaction scheme. And then I'll end up with a benzene with a C double bond O, CH2CH3, and then down here is going to be an SO3H. There you go. We've just made B as a product. Now, let's take a look at C. C was probably a trick, and this is why. You probably are going to look at the C group, and you're going to look at this group up here, COOH, and this is a C double bond O with an OH group. And you're probably wondering, well, wait a minute now, that's not really a Friedel-Crafts acylation, and it's not really a Friedel-Crafts alkylation either. This is a carboxylic acid. In the Friedel-Crafts versions, we either had a straight upfront carbon chain that we added on, or we had a carbonyl, C double bond O, with other carbons that it brought to the party. Never at any point in time did we talk about the addition of that OH group that's there. So Friedel-Crafts is actually not the best route to make a carboxylic acid. We have to use maybe a Friedel-Crafts to get there, but Friedel-Crafts is not going to bring that OH group to me, which is what I need on that benzene ring. So this is going to be a trick, and the reason that this is somewhat of a trick is because this is a carboxylic acid, and this is a carbonyl bond, and at this point, if you look at the position of where this lecture material is in your textbook, this is coming after the carbonyl reactions, and that's not the way that I target Chem 252. I talk about benzenes first because they're a little simpler. So they want you to go back and they want you to pull out a carbonyl reaction that you were supposed to have talked about at this point in order to answer question C. And we've just not seen this reaction yet. So because of that, you maybe tried to dabble a little bit with C but couldn't quite figure it out, or you weren't very sure with the direction of where to go, and that's the reason. Because really, we haven't talked about this carbonyl reaction that we can take advantage of. All right, so I know that a carbon is going to have to go onto the ring. I have to elongate a chain. Friedel-Crafts does that very well for me, and I can use Friedel-Crafts to my advantage. So I can bring in a CH3 group with a Cl, and I can do that traditional AlCl3, and not add water here because I'm not really acylating. But what that will do is it will take my benzene and it will place a methyl group onto that benzene ring. It gives me toluene basically. Now, the trick here is to realize this group, as it's written, this is an R group, and an R group is an activator, and an activator goes O and P in order of directors. And on C, I need a M. It is a meta all over again. So this is not going to work. So this is a clear sign that I need to take care of this methyl group first. I need to get it out of a methyl group, and I need to see if I can come up with a way to make a COOH bond, a carbonyl. And this is the step that we haven't talked about yet. We can do this if we add chromic acid and some heat. H2CrO4, chromic acid and some heat will take that R group and it will convert it to a C double bond OOH group for you. This is the key. And this is the key that you didn't know at this point. I'm so sad. I'm so sorry. I failed you as an instructor. However, all of the other examples didn't include a carbonyl reaction, did they? No, they didn't. This was the first time that we saw this. So, I talk about benzenes first. I think it's a little bit easier. I think it gets you more comfortable with the class and the material. And then I sock it with the carbonyls. You will get a 1, 2, 3 punch because I go in for the knockout when carbonyls begin to happen. All right, so this is the production of the benzene with the carbonyl and the OH. All right, now with that said, we now can go the next step because this group is a deactivator and it's a meta director, and we need to add on an NO2, so I'll add on some nitric acid, HNO3. Let me get rid of that. That was a horrible scribble. HNO3, and then sulfuric acid, H2SO4. And then that will end us with the product that we want. All right, so that middle step was the key step. That middle step you did not know, and that's okay. We haven't talked about that yet. But I can take an R group like CH3. I can put chromic acid in with that mix, and we can convert that thing over to a C double bond OOH in doing so. All right, so there's the answers to that example problem for A, B, and C. All right, now let's take a look at another example. Show how each of the following compounds can be synthesized from benzene. A, B, C, D, E, F, G, H, I. I mean, they might as well have went to Z. I've highlighted, though, 4 of these. D, E, F, and G. And the reason that I highlighted them is because there's probably a step in here that we really haven't talked about because they went back to those old carbonyl reactions that we haven't talked about yet, but they assume that we know. So A, B, C, H, and I are very straightforward. We're going to talk about those. Those you should be able to answer at this point. So we're going to go through and we're going to go ahead and answer those together. And then D, E, F, and G. These are the areas where they might be a little tricky on us. So this you probably need a little extra help on, again, because maybe there's a component in here that we haven't talked about yet. Maybe there's a component that's fairly old that we need to go back and touch base on again. Maybe this is coming from the carbonyls that we haven't discussed. We just don't know. But D, E, F, and G, you will see last, and we're going to answer A, B, C, H, and I right now. All right, so let's get to it. Okay, so let's take a look at A, and A says orthobromopropylbenzene. All right, so that gives us a nice place to start. So I know that I'm going to have to end up making this structure. It is a benzene, And it says ortho. So let's say I'm going to put my first group there. My second group is going to go right beside of it. That's the O position. And it's bromopropyl. All right, so bromo and then the propyl group. So there we go. This is the product that we're going to have to make through multi-step synthesis, and we got to figure out how we do it. All right, so if I take a look at bromo, bromo group is a weakly deactivator. However, it is a O and P director. On the other side, I'm going to get this propyl group, and this is an R group. And an R group is also a OP director. And in addition to that, it's an activator. An R group is an activator. So if I had to think about the proper steps in order to make this product, I would probably want to put the activator on first, so that way the ring could be more reactive toward the next step, and that will be a better synthesis route for me. So out of these two choices, I'm probably going to end up taking benzene first, and then I'm going to react this with a carbon-carbon-carbon chlorine. And with that said, maybe I can bring in the aluminum chloride, AlCl3, with number 2, water. And the answer is no water, because this is not a carbonyl. Okay, so if I do this, then I'm going to go, okay, fine. So I'm going to take this benzene ring, and then I get the freedom to put this alkyl group wherever I want to put it. So I'm going to put it here, here, and there, right? I mean, that matches the product. That's wrong. You're not going to do that. And this is why. This is why this is incorrect, folks. Go back and take a look at Friedel-Crafts alkylation. When we add the alkyl group on, what we discovered with Friedel-Crafts alkylation is rearrangement will take place. This was a problem for us. We said that if we alkylate, the alkyl group is great, and no big deal. It's going to go on, but it's not going to go on like this. And the reason is because this chlorine leaves and it forms a carbocation, and the carbocation will shift. And that will be the new site of location as far as attachment goes. So because of the rearrangement, we will never be able to get a straight chain carbon onto a benzene ring. So the setup like I have it right now, folks, it's not going to work. And that's because I cannot get a straight chain carbon onto that benzene ring. I've got to think of something else. But we talked about that when we talked about the differences between the alkylation and the acylation. We talked about how we can fix this problem. So to fix it, to make sure that we get something to go on like we want, we still have to acylate this piece. When we acylate the piece, that prevents this carbocation from rearranging. So we can get a 3-carbon chain. The problem is that the C double bond O is also going to be there. And now we do have to have water. That is a required reagent for this reaction to go forward. So I get this benzene ring. This benzene ring now has a 3-carbon chain on it. And this 3-carbon chain with a double bond O, I've got to go through and I have to destroy that C double bond O. And we talked about how to do this back in the day. Back in the last lecture module, we said that we could take H2, palladium, Lindlar's catalyst, platinum, whatever the case was, and that will destroy the double bond characteristic that comes from that reagent, or the product from the first step. So this will end up giving me my 3-carbon chain that I need onto that benzene ring. But we're not quite done, right? So we said that once the propyl group goes on, it is an activator. Ding! Okay, good. We've made the benzene ring more reactive. That's great. And it's also an ortho para director, which is good news. because that's exactly where we need the bromine to go. So now at this point, how do we get a bromine onto the benzene ring? Oh, well, that's pretty easy. We just take Br2 and FeBr3, folks. That's all that we need to do at this point. So my 3-carbon chain does not get touched. Ortho to that, either direction would be okay. Now this will slap on a bromine, and I will get the product that the question wants. So that is the synthesis of number A. We have to acylate it first. That prevents rearrangement. After the acylation, we destroy that carbon double bond O with H2. That H2 will then destroy the double bond characteristic, giving me the alkyl group, which is what I needed. And then we brominate it in order to place the bromine on the ortho spot. All right, so there is the answer for A. All right, now for B. B said that this is what I need to make. It's a benzene ring, but it's benzoic acid. All right, so that's a C double bond OOH, right? There's benzoic acid. Well, we also need a nitro group on it, and it needs to be in the meta position. All right, so ortho meta, and this is an NO2 group. So this is what I need to make. Now, I didn't highlight this one yellow because you're going to go back and be, well, I thought you told me that we didn't know how to make the C double bond OOH. Well, you do now. You do know how to do it now. So I'm including that into a reaction that you should know at this point that we can take advantage of. We haven't talked about carbonyl reactions. I know that we haven't. But this is a reaction that we've just spoke about. So we're going to use it yet again, just as a quick review to kind of reconfirm what we just learned. So at this point, I'm going to take my benzene ring, and we've got to figure out the proper order in order to get these groups on. All right, so the NO2 group, this is a deactivator, and this deactivator is a meta director. Okay, so that's good news. We need this meta. All right, so that would work. This C double bond OOH, this is also a deactivator. That deactivator will give me a meta position. That's great news because that's what we want to, right? Meta. So as far as the metas go, either one of these would work. That's exactly what I would need. But there is a decision to be made, and that decision is which one comes first. Is there a priority? And there is. And the reason is because we're elongating a chain. This is probably going to include a Friedel-Crafts. If I have a deactivator on it first, the Friedel-Crafts is not going to go forward. So I need to put the Friedel-Crafts on it first. In other words, chain elongate first every single time when you can. All right. So I'm going to take this benzene ring, and I'm going to add to this what we did before. Methyl with a chlorine. And I'll need AlCl3 in order for that to work. Well, what happens is that the benzene will take on that alkyl group. There's only one carbon, so there it goes. We've talked about how to fix this. We said that we can chromate it with a little bit of heat, and that will give us a C double bond O OH at that point. All right, so step one is now done. We now have the proper group onto the benzene ring. That group is a deactivator, but that's okay. And that group is a meta director, which is exactly what we need. Well, from that point, I need to put a NO2 group on. That NO2 group is going to come from the addition of HNO3 and H2SO4. I'm nitrating it. So I'll get the carboxylic acid piece, and at the meta position, I now have added my NO2 group. So there you go, folks. A quick review of taking an alkyl group and converting it to that carbonyl of a C double bond OOH with the use of chromic acid. Again, we haven't talked about that. We haven't dabbled into the world of carbonyl reactions yet. We will. But at this point, That is a new reaction that was introduced just a couple of minutes ago. Now, let's take a look at our next one. C. C says, give me a benzene ring, and this is going to have benzoic acid yet again. And P, para, means directly across, and a nitro group. Oh, wow now. This might be a little different. Let's talk about why. It's the same groups that we had before. What's so hard about this one? It's a little tricky. We said in the last example that NO2 is a deactivator. And that deactivator is a meta position. That's not meta. This is para. Okay, the C double bond OOH. We said that this was a deactivator. And because of that, that is a meta director. Oh, wow. Both of these are meta, but they have went on para of each other? How does that even happen? Well, sit back and watch. We're going to start with our benzene ring first, just like before. That's what it tells us to do. And we're going to add on, for the same reason, CH3Cl with AlCl3 as a catalyst. And that will add on to this benzene ring a CH3 group, right? We said that we have to chain elongate first in a way because a deactivator on the benzene ring will prevent the chain elongation from the Friedel-Crafts from going forward. So this is a have-to step right there. Now, in the previous example, what we did is we chromated it immediately, and that changed it over to a C double bond OOH. If I do that, though, that will give me a deactivator, and it will give me a meta position, and that's not what we want. It's the group that we want, but it's not the director that we want. So, we have to kind of pause for a minute. Look at this group that's on the benzene ring right now. The group on the benzene ring is a methyl group. This methyl group is a activator. And that activator means that it's a OP director. And that's good, because that's what we need. We need something to go on para. So instead of me chromating it right now, what I need to do at this point is I need to go back and I need to take a look at this reaction setup, and I need to modify it from the previous example. The way that we modify this is we are going to add in this step nitric acid and sulfuric right now. We're not going to convert the methyl group over yet. If I do, I lose my ortho-para director. I need that director. I need it to go on para. So when I do this, this benzene ring is going to keep the methyl group. The methyl group is a para director, and that para director will slap on the NO2 group where it needs to go. Okay, that's good, but my job is not yet done. I've taken advantage of the methyl's director. So at this point, now I can work on my methyl group side once more. And I do that just like I did before. I'm going to add H2CrO4 with a little bit of heat. And what happens is that it takes my methyl group, it converts that to that carboxylic acid, and NO2 group goes para. It doesn't get touched by the chromic. Only the methyl group will get touched by the chromic. So there is your reaction flow scheme for example C to make para nitrobenzoic acid. All right, now we're going to skip because those others were highlighted, and we're going to work on H. So H tells me that I need to make a benzene ring, and on this benzene ring I have a meta, and there's a bromo on it, so there's where I'll start, and meta to the bromo is going to be a propyl group. There we go. Okay, so let's figure out how to do this one. My bromo group is a slight deactivator, However, that deactivator is orthopara. The propyl group is an R group, and that R group is a orthopara. It's an activator. Uh-oh. We've got another problem. A bromo is going to OP it. My alkyl group is going to OP it. But I don't have an OP. Oh, shoot. I have a meta. So that means that these groups are not going to work. Folks, I've got to come up with something else. I've got to come up with another plan. All right, well, what is that other plan? Again, it's a trick. You got to think about these. I need something that is meta. If I do something that's meta, though, a meta is a deactivator. And that deactivator, I need to elongate a carbon chain, which means I probably need to do a Friedel-Crafts first. All right, I need to come in here with an AlCl3 reagent, and I need to Friedel-Crafts it. I can't just Friedel-Crafts it, though, with a 3-carbon chain, but I can get clever. I can do a 3-carbon chain with a double bond O and a Cl right there. And if I do this, look at what happens. This group is going to go on, and there's a double bond O carbon-carbon. That's how that group goes on. It prevents rearrangement. It makes sense. I would have to do that anyway, even if I wanted a straight chain 3-carbon. This is the first step that I would have to go through. Otherwise, it would rearrange on me. Now, to do this, it's great. C double bond O with 2 more carbons, a chlorine, my AlCl3, right? Water. I get this group onto the benzene ring. This group, though, now is a deactivator. That deactivator is a meta director, and that's good news. Hallelujah. And the reason that's good news is because my bromine at this point is in the meta position. So before I do anything else to this group, what I want to do now is add my bromine with my FeBr3, and that will put my bromine on the position of where I need it to go. There we go. I'm not quite done, though, because look, I've got the C double bond O hanging out off of the ring, and I need to convert that to a 3-carbon chain. I need to destroy the double bond characteristic. Do you remember how we did it? Well, if you said add just H2 and palladium or platinum, some type of Lindlar, doesn't really matter how you write it, just H2 it, we're going to hydrogenate it. That will take my benzene ring with my Br, and now my 3-carbon chain is in place. Folks, it's all about the order. It's all about the proper setup. It's all about the directors and the locations of where these things need to go. And if you ignore all of those, you're going to have a problem. All right, now we've got one more, and that was I. And I says 1-phenyl 2-propanol. Oh, goodness. All right, so propanol. Prop is 3 carbons, 1, 2, 3. And on the second carbon, because it says 2-propanol, I have an OH group. And then it says 1-phenyl. All right, so off of this first carbon, a phenyl group is a benzene that is directly attached to the ring. This is what we need to end up with. How on earth do we get that particular type of product? Okay, well, let's take a look here. If I have this benzene ring really only has one group on it, right? I mean, I don't have to worry about ortho directors and para directors. There's just one group. So the idea here is to get a group onto the benzene ring, and once I get the group onto the benzene ring, then I can figure out how to get that OH group onto the benzene ring. So this is where I'm going to stop the video. I want you to kind of think about this for a minute. How would you make that compound that you see on the screen right now? I told you that you should be able to do this without talking about any extra reactions at this point. So how would you do it? A benzene with a 3-carbon chain and an OH group. Only one group is on the benzene. That's it, no more. So we've got to come up with a way to make that. Can you do it? So take a few minutes, think about it, and then push play on the next video to see if your thought process was going down the same path as mine. Good luck.